Hello everyone. Today we're going to be doing a October-November 2024 paper, and this is paper 11. So it basically tells us there's a lift which consists of passengers, which is supported by a cable that runs over a frictionless pulley to counterbalance. Okay, so you can basically ignore this part, and the counterbalance falls as the passenger car rises. So obviously, right, if this part of the system falls, the other part will go up. So that is fine. And we're given some masses of the different people and things on here. And we need to calculate the magnitude of acceleration when you're carrying one passenger. So let's imagine this as a free body diagram. If this is the pulley, we can imagine this being the counterbalance, right? Wait, I'll just write, it'll be easier like this, right? Here being the counterbalance, and this is 640 kilograms, so we can do 640 G. Now similarly, we have one in this side, right? This is pulling down with 520 plus 80, which will be 600 G's, right? G is the gravitational field strength. So if we just imagine it, we can see there's more being pulled in this side compared to this side, right? This has a greater force which is pulling down. So what will happen? This part will fall and this part will rise up. So now we need to calculate the resultant force. So what will be the net force of this? We can just subtract this. So 640 G, which is the gravitational field strength again, minus 600 G will be equal to 40 G. And if we just do that, we get 40 times 9.8, which is equal to about 392 newtons. So this is a resultant force. And now we can use a simple formula, right? We can use force equals to mass times acceleration. Now, what many people would get tripped up over here, they'll take the mass of this, the passenger car and the elevator. This will actually be incorrect. If we imagine it, we're taking the entire thing, the counterbalance, the rope, which you can ignore here, the passenger and the lift or the elevator together. We know if the passenger car is going up or accelerating at 1 meter per second squared, the counterbalance will be falling down at 1 meter per second squared. So this entire system, the entire contraption is part of the system. So the mass over here would actually be 640 plus 80 plus 520 over here. And if we do 392 divided by 640 plus 600, which is 1240, right? If we do that, we'll get the acceleration as 0.316, which rounds up to 0.32, giving us the answer of option B.